All right, let's dive into something really cool today. We're going to talk about a new approach to AI that, honestly, doesn't just tweak what we've got, it pretty much throws out the old rulebook. It's called the Recursive Fractal AI Model, or RFAI for short. And you'll see it offers a pretty wild solution to some of the biggest headaches we're facing in AI right now.
You can see the huge difference right away. You know the old way of thinking in AI, right? For years, it's been all about bigger is better. More parameters, more data, more compute. But what does that get you? These massive, bloated, energy-guzzling models that cost a fortune to train and run. Well, RFI completely flips the script. It's all about being lean, using fewer parameters, saving energy, and scaling in a way that, frankly, today's models can only dream of.
And look, this isn't just some marketing buzzword. The people who design this thing are serious. They see it as a true paradigm shift. We're not just talking about, a slightly more fuel-efficient engine. No way. This is like rethinking how you build a car from the ground up. It's a total move away from brute force computation and towards something much more elegant, something inspired by nature itself.
So, you might be asking, why do we even need a shift this big? Well, it's because, in a lot of ways, AI is hitting a brick wall. This endless race to build bigger and bigger models has created a huge sustainability problem. The cost, the sheer amount of energy they burn, the mountains of data they need, it's all spiraling out of control.
And here's the real kicker. We're getting less and less bang for our buck. It's a classic case of diminishing returns. You can double the size of a model, but you are definitely not doubling its intelligence. As the problems we're trying to solve get harder, our current methods just get more and more inefficient. We're building these gigantic digital brains, sure, but they're constantly starving for more power, and the actual improvements are getting teeny tiny.
Okay, so if building bigger isn't the answer, what is? Well, this is where it gets really interesting. The creators of RFAI looked at nature. I mean, think about it. Biological systems, from our own brains to whole ecosystems, are unbelievably efficient. And what do you see everywhere in nature? Fractal patterns. Nature doesn't just build bigger, it builds smarter. It uses simple, repeating rules to create mind-boggling complexity. And this next question just nails the core idea. Think about a skyscraper. It's built piece by piece, brick by brick. It's huge, it's static. But a fern grows. It unfolds itself from a tiny, simple set of instructions, repeating the same basic shape over and over again at different scales. That is the heart of the fractal approach. So to really get this, we only need to wrap our heads around two key ideas. First, a fractal. It's just a pattern that's self-similar, meaning the same basic shape shows up again and again at different sizes. You see it everywhere: coastlines, snowflakes, tree branches. And then there's recursion. That's simply the process that makes the fractal. It's a simple rule that just calls itself over and over to build something really complex from a simple starting point.
RFI brilliantly smashes these two ideas together. So instead of having this massive pre-built network with billions of parameters just sitting there, an RFI model starts with a tiny set of these recursive rules. And here's the key: it doesn't store all that complexity. It unfolds it when it needs it. It grows the structure it needs to solve a problem right on the spot. So how does the engine that pulls this off actually work?
All right, let's get into the mechanics. The adaptive fractal engine. How does this thing actually generate, encode, and learn? Okay, first up is the generation engine. It's got a fancy name, the Adaptive Multiscale Iterated Function System, or AMIFS. Just think of it as the system that lays down the rules for how the AI grows. It starts with a base part that creates the main fractal shape. But, and this is crucial, it has an adaptive part that changes the pattern based on the data it's looking at, and a contextual part that tweaks things based on its own history. It's not static, it's like a dynamic, living thing. Now, this leads to a completely different way of thinking about information. In your typical AI, information is just, well, a long list of numbers. But in RFAI, the basic unit is something called a fractal information motif, or FIM. A whole concept, like the idea of a cat or the action of running, is actually encoded into the geometric shape of a pattern. Let that sink in. In this model, the information is the geometry. And if information is geometry, then learning isn't what you think it is. It's a process called recursive structural adaptation. An RFAI model doesn't learn by just nudging billions of tiny weights up and down. No, it learns by physically evolving its own structure. So if one part of the fractal isn't doing a great job, it might literally split in two, bifurcate to create more specialized pieces. And if two parts are doing the same job, they merge to become more efficient. Learning is, quite literally, evolution.
Okay, so we've talked about how it works, generating complexity on the fly, encoding info as geometry, learning like a living thing. Now let's talk about the payoff, because this unique setup unlocks some absolutely radical gains in efficiency.
This one word is everything: logarithmic. Here's what that means. In today's AI, if a problem gets, say, 10 times harder, the cost to solve it might go up 10 times, or even 100 times. That's linear scaling. But with RFI, the cost scales logarithmically. This is a massive deal. It means that as problems get exponentially more difficult, the amount of power you need to throw at them grows just a little bit. For tackling huge, complex challenges, this is an absolute game changer.
And this chart just lays it all out, plain and simple. Look at the comparison. Everywhere that conventional AI struggles, the fractal approach just shines. Scalability? We go from linear to logarithmic. The insane number of parameters? Slashed dramatically. Energy use? It basically plummets. And it's way more data efficient too, because it can learn a pattern once and apply it everywhere.
The memory savings are just as mind-blowing. An RFI model doesn't have to keep a huge map of its entire structure in memory. All it needs to store is the tiny formula, those simple recursive rules that can generate the structure whenever it's needed. I mean, think about it. It's the difference between saving a gigantic 1 gigabyte photo file versus saving the few lines of code that can draw that exact same photo from scratch.
So, what does this all mean for the future? What does a world with this kind of AI actually look like? Well, when you're suddenly free from the chains of massive costs and insane energy needs, a whole universe of new possibilities just opens right up.
I mean, just imagine it. We're talking about super powerful AI running right on your phone or on a tiny little sensor, no cloud needed, all because it's so incredibly efficient. This could completely change the game for modeling huge, complex things like climate change or the global economy. It's tailor-made for scientific discovery, for finding those hidden patterns in our DNA, and for finally cracking the recursive puzzle of human language. Not to mention, it could lead to self-driving cars and robots that are way, way more efficient.
So, at the end of the day, this isn't just one more AI model to add to the pile. The creators themselves see it as a fundamentally new direction for the entire field of AI research. It's a way to get around that massive resource wall that's holding us back, and it could unlock a whole new generation of AI that's not just more powerful, but also accessible to everyone.
Which really leaves us with this one big question to chew on. For so long, the race in AI has been about building bigger and bigger brains. But what if that's the wrong race entirely? Maybe the future isn't about these giant construction projects at all. Maybe it's about something much smaller, planting smarter seeds. You know, these tiny, elegant sets of rules that have everything they need to grow into true intelligence, all on their own.